Hello everyone, happy to see you here. Welcome back to my channel, Hi Mathematics. Today we have a very interesting question, x to the power 6 equal to x minus 1 to the power 6. We need to solve this question for x, so if you have your solution, your answer, you can also write it in the comments below and then we will check your answer, so it will be really interesting. So first of all, let's write this expression on the left side, okay, but with the negative sign, so I hope you understand it. Right now we have x to the power 6 minus x minus 1 to the power 6, x minus 1 to the power 6, and equal to 0. Okay, so I really hope you understand this first step. What are we going to do next? Instead of this x to the power 6, let's write x to the power 3, yeah, raised to the power 2, something like that. And the same thing with this expression on the right side. So as a result, we have x minus 1 to the power 3, but I'm going to use a different brackets. I'm going to use this one. I really hope you understand it. I'm going to use this type of brackets, raised to the power 2 equal to 0. And right now let's see this question like from a different angle, because everyone should know this formula. For example, this is our a and this is our b, but from a different angle we have a square minus b square. So this is our classic school formula. We have a square minus b square equal to a minus b or a plus b, so a plus b times a minus b, So right now let's apply this formula right here at this place. So let's do it right now. So as a result we have x cube with the plus sign, so plus x minus 1 cube, yeah, the first parenthesis, and the second parenthesis x cube minus x minus 1 cube, and equal to 0. So I really hope you understand it. According to this property, we solve this question. We do the step absolutely correct. Right now, let's see this question. Let's look at this question from a different angle. In the first parenthesis, we have x cube plus x minus 1 cube. So saying in other words, we have a sum of two cubes. In this parenthesis, we have a difference of two cubes. So right now, let's remember these formulas. I'm going to write this formula right here on the left side because we really need to know these both formulas. First of all, I'm going to start with the sum of two cubes. So a cube plus b cube. This is our first formula, equal to a plus b, and times parentheses we have a square minus ab, and plus b square. Okay, this is our first formula, and we're going to apply this formula at this place. And second thing, we're going to have the same formula, but with the a cube minus b. We will have the same thing, but right here negative, right here positive. So I don't need to write this formula once more. So right now let's try to expand these expressions according to this formula. I'm going to start on the left side because it will be like a long, really long line. So first of all, let's expand this one, x cubed plus this expression. So we have x plus x minus 1, this is our first parenthesis, and we have the second parenthesis, x square minus x times x minus 1 plus x minus 1 square. This is our first parenthesis. So we expand this expression, a sum of two cubes. This is our expression. Right now let's do the same thing with the second part. We will have absolutely the same signs, but right here negative, right here positive. Okay, so I really hope you understand it. So we have x minus 1, and we have the second parenthesis. So we have x square plus x times x minus 1, yeah, and the last step, so minus x minus 1 square, minus x minus 1, we have right here square, and equal to 0. So I really hope you understand that. Right now we're going to simplify it, and everything going to be great. So first of all, right here we can easily cancel this x, so we have x and x, we can easily cancel it. And right here we have x plus x, we have 2x, so 2x minus 1 in this parenthesis. So let's start with it. So we have 2x minus 1 in this parenthesis, 2x minus 1 in these parentheses. Right here I'm going to write on the second position, I'm going to write this expression, so this one equal to 1, yeah, so as a result we can easily cancel this x. Right here we have only 1, I'm going to write this one right here. The second parenthesis, let's simplify this expression, so we need to simplify two expressions. This is this parenthesis and this parenthesis. So let's start, for example, with this one. So we have x square, yeah, x square minus x times x minus x square plus x plus x, and we need to raise these to the second power, so plus x squared minus 2x and plus 1, plus x squared minus 2x and plus 1, plus 1. Okay, yeah, I hope you understand it. And right now, these parentheses, let's do it. So this is this parentheses, so I draw this line, and of course these parentheses. First of all, we have x squared plus x squared minus x. So x squared plus x squared minus x. And this formula right here, x minus 1 to the second power, so we have plus x squared and minus 2x, and plus 1 is equal to 0. Yeah, so right now let's simplify this. So x squared minus x squared, we can easily cancel it from here. Yeah, what can we get once more? X squared plus x squared, we can easily add it. So with this x squared, so right now let's try to group everything we need. Okay, let's do it. So first of all, we have 2x minus 1, 2x minus 1. Second parenthesis, what can we get from here? So we have x squared minus 2x plus x, we have minus x, so x squared minus x plus 1. Yeah, so we have x squared minus x and plus 1, x squared minus x and plus 1, and the third parenthesis, so we have x squared plus x squared plus x squared, we have 3x squared, so 3x squared, minus 3x right here, so yeah, we have minus 2x minus x minus 3x, and plus 1 from here. Plus 1 is equal to 0. Really great. So right now we need to solve it. So we have a product of three parentheses, so a product equal to 0 when the first parenthesis equal to 0. So we have the first case, so 2x minus 1 is equal to 0. This is our first case. From here we can easily solve it real quick. So 2x minus 1 equal to 0. So 2x equal to 1 and x equal to 1/2. Okay, this is our first real number root. Yeah, we solved it. We have first real number root right here, so x equal to 1/2. Second parenthesis right here, so we have x squared minus x plus 1. Yeah, so we have x squared minus x and plus 1 equal to 0. And the second case, we need to solve this quadratic equation. I'm going to solve it on the right side, so 3x squared minus 3x and plus 1 equal to 0. Right now let's solve each of these quadratic equation, and then we can get from here more roots. Yeah, so first of all, there are a lot of ways how can we solve this question, but I prefer a classic with the method of coefficients. So from here, a equal to 1, b equal to minus 1, and c equal to 1. Right now let's find real quick a discriminant. So let's do it. So discriminant equal to b squared minus 4ac, which is equal to b squared minus 1 squared minus 4 times 1 and times 1. So from here, our discriminant is equal to 1 minus 4 equal to minus 3. So our discriminant is negative, is less than 0. So it means that in this branch we will have two complex roots. Okay, so I really hope you understand it. Right now let's find it. So as a result, this is our x first. So in this branch, let's use, for example, x second and third, which is equal to minus b plus minus square root of d all over 2a. Let's plug in this each of these elements into this spot. So we have minus b equal to minus 1. So we have minus 1 plus minus square root of discriminant square root of minus 3 and all over 2a 2 times 1. From here, what can we get? Minus 1 equal to plus. So we have 1 plus minus. This square root of minus 3 we can write as square root of minus 1 times square root of 3. We can easily split it, and we divide it by 2. Right now, this square root of minus 1 equal to I. This is our imaginary unit, so we can easily write it as I, and we can divide it by 2. So we can divide 1/2, so we can get from here 1/2 plus minus I square root of 3 over 2. So we have 1/2. I just want to split it by real part and imaginary part. So we have 1/2 plus minus I square root of 3 over right here over 2. This is our real part. This is our imaginary part. So we have x second and x third. We have two complex roots. Right now, let's go to the last equation. This is our last equation on the right side, and let's use the same method as we solved it before, method of coefficients. So we have a equal to 3, but first of all, let's split it like that, because maybe there are a lot of students who get confused because of this solution. Yeah. So right now, a equal to 3. B equal to minus 3, and c equal to 1. Let's solve this quadratic equation. First of all, let's find the discriminant, equal to b squared minus 4ac, and this is our discriminant, equal to, so we have b squared minus 3 square minus 4 times a times 3 and times 1. As a result, what can we get from here? So we have 9 minus 4 times 3. We have right here, we have 12, yeah? 9 minus 12. And as a result, our discriminant is also negative. So it means that in this branch, we will have two complex roots. So let's do it right now. Let's plug in it into all known spot right here. So x second and third, we know this formula. So let's write it as x fourths and fifths, yeah? As a result, we have minus b minus 3 plus minus square root of discriminant, square root of minus 3, and all over to a equal to 3. So all over 2 times 3. So x fourths and fifths equal to, we have minus 3, we have plus, so we have 3 plus minus, the same logic as we did before. This is equal to I square root of 3. So I square root of 3 over 6. And the final step, of course, this is up to you, but I prefer dividing this to split it by real part and imaginary part. So x fourths and fifths equal to, so 3 over 6 equal to 1/2, plus minus I square root of 3 over 6. So I square root of 3, right here, I square root of 3 over 6. Of course, right here we can do a really interesting trick, and of course I'm going to show you this trick right now. So let's split it like that. So we have x to x fourths and fifths equal to, so we have 1/2 plus minus I square root of 3. I'm going to multiply it by square root of 3 right here, yeah, square root of 3, and we're going to divide it by 6 times square root of 3. Okay, I'm going to do it like that. Square root of 3 times square root of 3 equal to 3. And 3 we can cancel with this 6, so we have only 2 in our denominator. So our x fourths and fifths equal to 1/2 plus minus, 1/2 plus minus I over 2 square root of 3. And this is our real part. Right here, this is our imaginary part. So yeah, we solved this question. Right now I'm going to group all these answers right here on the left side, and then we will check real quick our x first equal to 1/2. So that's why I'm going to group right here x second and third. Let's do it right now. So x second and third equal to 1/2 plus minus I square root of 3 over 2. This is our x second and x third. Yeah, I'm going to group it right here, yeah. So as a result, what can we get from here? We can write x fourths and fifths at this place. So x fourths and fifths equal to, so 1/2 plus minus I over 2 square root of 3. Yeah, these are x fourths and fifths. Really great. Right now, let's group it. And right now, in the end, let's check real quick our, for example, let's check x first equal to 1/2. Let's do it right now. But before checking this, I'm going to show you one really interesting and tricky move, because there are a lot of students, they say, okay, we have x to the power 6. I'm going to write it. So x to the power 6 equal to x minus 1 to the power 6. A lot of students, yeah, to be honest, a lot of students, they say, okay, maybe we can cancel this 6 and this 6, and they say, okay, we're going to cancel it. And as a result, what can we get from here? X equal to x minus 1. And from here, we have what? We have 0 equal to minus 1. And a lot of students get confused because they think that this is a correct way. Of course, you can do this in terms of your math calculations, math solutions. You can easily do this. You can easily cancel this 6 power, of course, yeah, without any problems. But one really important moment, a lot of students forget about absolute value. So if you cancel this power, you need to put absolute value right here, and you need to put absolute value on the right side, x minus 1. And with these absolute value brackets, everything is great. From here, you can easily get one root. So x first, you can easily get from here. You can easily solve it. It's up to you how you prefer solving this question. Maybe with the method of combinations, like right here positive, negative, positive. And you know, this is up to you how you solve in this absolute value equations. But from here, from this branch, you can easily find x first. Why this method is good and why this method is not good? This method is good because, for example, you don't have enough time on your exam, and you basically you don't have enough time, so you don't have enough time to simplify it, to factor it. So then you can easily cancel this 6 power, and then you can easily, with absolute value, of course, because this is a tricky moment. A lot of students don't understand it, and this is not a good way to solve this type of question. A correct way to put absolute value brackets, and if you don't have enough time, you can find x first from here. And then, of course, you don't solve this question completely, because you solve only one, you find only one root. But if you don't have enough time, this is okay. This is a great way. But as you can see, there are 4 more roots. So we have 2 complex root and 2 complex root more. So it means that you missed 4 roots. And if you want to solve this question completely, you just need to solve this question like that, with the factoring, with these really important tricks, and then you can easily say, okay, I solved this question completely. Because according to a fundamental theorem of algebra, for example, right here we have x to the power 6. Yeah, we have right here our question x to the power 6. And according to a fundamental theorem of algebra, it means that we have 3 roots, 6 root in total. What does it mean? It means, maybe someone doesn't know theorem of algebra, fundamental theorem of algebra. It means that, for example, we have a question right here, yeah, and we need to scan what is the highest power. So, for example, in this case, the 6 is the highest power in our question. So it means that we have 6 root in total. We don't know how many real number roots, how many complex number roots, but we have 6 root in total. And this is exactly our case, because we have 6 power is the highest power, so it means 6 root in total. And we have 1, 2, 3, 4, 5, and right here we have 6 root with this 1, but doesn't matter. Basically, we solved this question completely, and I really hope you understand this moment with this fundamental theorem of algebra. So once more, here's our solution to this question. You can easily see it. You can easily pause the video and try to solve this, try to understand it. But if you still have any question, write a question in the comments below. Here's our solution. Here's our fundamental theorem of algebra, and here's a tricky moment, because a lot of students solve this question absolutely incorrect because of this absolute value. So put this absolute value. If you don't have enough time, you can easily find x first. If you want to solve this question completely, here's a solution. So you can easily see it from a different perspective. And in the end, I'm gonna check real quick of x first equal to. So let's do a quick proof right here. So let's check real quick our x first equal to 1/2. So let's check real quick. As a result, what do we have? 1/2 to the power 6. Let's check it. Equal to 1/2 minus 1 to the power 6. And from here, what can we get? 1/2 to the power 6 on the left side, and on the right side we have minus 1/2 to the power 6. But basically these are the same expressions. Yeah, we have 1/2 to the power 6. Okay, and right here we have minus 1/2 to the power 6, or we can write it as minus 1 to the power 6. We can split it, yeah, times 1/2 to the power 6. And in this way, minus 1 to the power 6, this is our even power, so it means that the final sign will be positive. And basically, I really hope you understand it. When we have an odd power, so 3, 5, 7, we have a negative, because when we multiply it, we have basically a negative sign, because when we group it together, we have a positive sign. And exactly in this case, we have minus 1 to the power 6, so we can easily group it. And I really hope you understand my solution. So our root, it means that our root is absolutely correct. So once more, a solution to this question. I really hope you understand my thoughts. I really hope you understand my notes, my prompts, my tips, and I hope you understand this solution. You can also write your thoughts, write to respond in the comments below. Write your way. How do you see this solution? Maybe you have your answer, your approach. Also write it in the comments below. So once more, you can easily see a solution to this question. And few really interesting tips. The first tip, a lot of students cancel this 6 power, and the second tip, try to put absolute value and everything will be fine. But one really important moment, you missed 4 roots, and this is, you can't call this question as a completely solved one. Okay, with this complex root right here, you can easily say, okay, I solved this question completely and step by step. So I want to say thank you everyone for watching, thank you everyone for supporting my channel. We have a really big community right here, we have really different and interesting people, and I'm very grateful that we are all here and we are all solving these different questions. So I really want to say thank you everyone for being here, for supporting my channel, and I'm really grateful, and thank you for everything. We have a really great channel, different questions, and I want to do more and more. So I really want to say thank you for watching, for your support. It's also really great, and I'm extremely grateful and thankful for everything you do for my YouTube channel. It doesn't matter, it's a good video, it's a bad video. I appreciate your response, because for example, I have my own way how I prefer solving these questions, and for example you have another one, and it's also really great to discuss a little bit about this type of questions because there are a lot of people, a lot of countries, and everyone learn math in a different way. Of course, a correct answer is absolutely the same for doesn't matter where do you live, but according to different side of math, you have your own way, and it's also really great when you write it from a different perspective, your thought, your response. There are a lot of students here, and I want to say yes, thank you for watching my channel, and I really hope you learned something new. And if you do, you can easily leave your response in the comments below. So thank you for your time, take care of yourself, and have a great day. See you in the next videos.